Transmission lines. So first we will see introduction of transmission line. Transmission line is used for the transmission of electrical power from generating substation to the various distribution units. It transmits the wave of voltage and current from one end to another. The transmission line is made up of a conductor having a uniform cross sectional along the line. Air acts as an insulating or dielectric medium between the conductor. For safety purpose, the distance between the line and the ground is much more. The electrical tower is used for supporting the conductors of the transmission line. The tower are made up of a steel for providing high strength to the conductor. For transmitting high voltage over a long distance, high voltage direct current is used in a transmission line. In electrical engineering, a transmission line is specialized cable or other structure designed to conduct electromagnetic wave in a contained manner. The term applies when the conductors are long enough that the wave nature of the transmission must be taken into account. This applies especially to the radio frequency engineering because the short wavelength means the wave phenomenon arises over very short distance. So, the theory of transmission line was developed to explain the phenomenon on very long telegraph lines, especially submarine telegraph cables. The transmission lines are used for the purpose such as connecting radio transmitter and receiver with their antennas, distributing cable television signals. Also, trunk lines routing calls between telephone switch centers, computer network connection, and high-speed computer data bus. Ordinary electrical cables suffice to carry low frequency alternating current and audio signals. So they cannot be used to carry current in the radio frequency range about the 30 kilohertz because the energy tend to radiate off the cables as a radio wave, causing power losses. So transmission line is nothing but is long conductor with special design to carry bulk amount of generated power at very high voltage from one station to another as per the variation of voltage level. In transmission line, determination of voltage drop, transmission efficiency, line loss, etc. are important things to design. These values are affected by the line parameters, that is R, L and C, that is resistance, inductance and capacitor of the transmission line. High frequency interconnects require special consideration because they often behave not as ordinary wires but rather as a transmission line. In low frequency system, components are connected by a wire or the PCB traces. The resistance of this conductive element is low enough to be negligible in most situations. This aspect of circuit design analysis changes dramatically as the frequency increases. The RF signal do not travel along wires or PCB traces in straightforward fashion that we expect based on with low frequency circuit. The behavior of RF interconnect is very different from that of the ordinary wire carrying low frequency signal. So the additional terminology is used and it is a transmission line. It is nothing but simply a pair of conductor that must be analyzed according to the characteristic of high frequency signal propagation. Now what is cable? Cable is a convenient but imprecise word in this word. The coaxial cable is certainly a classic example of transmission line. The general idea is that the transmission line effects become significant when the length of the line is comparable to or greater than the wavelength of the signal. A more specific guideline is one-fourth of the wavelength. If the interconnect length is less than one-fourth of the signal wavelength, then the transmission line analysis is not necessary. The interconnect itself does not significantly affect the electrical behavior of the circuit. If the interconnect length is greater than one-fourth of the signal wavelength, transmission line effects become significant and the influence of the interconnect itself must be taken into account. So, for very low frequency, transmission line effects are negligible. For medium frequency, only very long cable requires special consideration. However, at 1 GHz, many PCB traces must be treated as a transmission line, and as a frequency climb into the 10 of the GHz, transmission line becomes ubiquitous. Then the next is types of transmission line. So, there are four types: open wire line, coaxial cable, waveguide, and underground cable. The first one is open wire. An open wire transmission line is made up of two parallel wires. Non-conductive spacers are used between the wires to separate and support them. The distance between the conducting wire is anywhere between 2 to 6 inches. Advantage of this open wire is the open wire transmission line pair is typically used to transmit acoustic waves for telephone application. The advantage of the open wire line is its simplicity construction. There are three disadvantages. The major disadvantage of the open wire line pair is its high energy loss. Second one is the wire pair is capable of picking up random signals resulting in interference. And third one is noise is reacting to this transmission line. So in open wire transmission line, there are the conductors having two lines or the two wires which are separated by dielectric medium, whose one end is connected to the source and the other end is connected to the destination. These are low cost and simplest form of transmission line, but their installation cost is higher, as well as maintenance sometimes becomes difficult due to the change in atmospheric condition. Second one is coaxial line or cable. The line consists of center or inner conductor in a dielectric which is enclosed by a metallic shield which is flexible braided conductor of copper. A plastic jacket is molded over the entire line as a protective coating. The outer conductor acts as a grounded shield with only one inner conductor, means that it is used in unbalanced transmission configuration due to different parameters of both conductors. Advantages: coaxial lines are best suited for high frequencies. This type of lines does not radiate energy due to complete shielding. Coaxial lines are used in noisy locations. It is used where multiple lines and interfacing are run. It works up to 100 gigahertz. Disadvantages: common mode current occurs when stray current in the shield flow in the same direction as the current in the center conductor, causing the coax to radiate. A continuous current, even if small, along the imperfect shield of coaxial cable can cause visible or audible interference. The gaps or the holes in the braided shield allow some of the electromagnetic field to penetrate to other side. So the coaxial cable lines are formed when conducting wire is coaxially inserted inside another hollow inside another hollow conductor. These are termed as a coaxial as the two conductors share the same axis. These are widely used in application where high voltage levels are needed. Next is waveguide. A waveguide is a special form of transmission line consisting of hollow metal tube. The tube wall provides distributed inductance while the empty space between the tube wall provide distributed capacitance. The waveguide contact microwave energy at lower loss than coaxial cables. Waveguides are practical only for signals of extremely high frequency where the wavelength approaches the cross-sectional dimension of the waveguide. Below such frequency, waveguides are useless as electrical transmission lines. When the functioning as a transmission line through a waveguide are considerably simpler than two conductors cables, especially coaxial cable in their manufacture and maintenance. With only a single conductor, there are no concerns with proper conductor to conductor spacing or of the consistency of the dielectric material, since only dielectric in waveguide as air. A waveguide is not considered to strictly be a transmission line as it is not constructed with two separate conductors. It cannot support a sorry a waveguide is not considered to be a strictly not considered a transmission line because it is not constructed with two separate conductors. Instead, a waveguide will propagate a higher order mode which are classified as either transverse magnetic or transverse electric. This category, that is waveguide category of the transmission line, is used for the signal transmission at microwave frequencies. These are basically hollow conducting tubes as they somewhat resemble like coaxial cable line but do not have the center conductor as present in coaxial cable. The waveguides are metal tubes functioning as a conduits for carrying electromagnetic waves. They are practical only for the signals of extremely high frequency where the signal wavelength approaches the cross-sectional dimension of the waveguide. Wave propagation through a waveguide may be classified into two, which we have seen, that is transverse electric or transverse magnetic. Depending on which field, that is electric or magnetic, is perpendicular, that is transverse to the direction of wave travel. Wave travel along a standard two conductor transmission line is of the transverse electric and magnetic mode where Both fields are oriented perpendicular to the direction of the travel. The transverse electric and magnetic mode is only possible with two conductors and cannot exist in waveguide. The waveguide is typically used for high power applications such as high power microwave transmitter. Waveguide appear at first to simply be a either circular or rectangular pipe, and effectively it is an electromagnetic pipe. Next type is underground cables. At present, there are two types of underground power transmission cables which are assembled in a pipe and solid dielectric cable. The first type is circulated around the cable in order to control the heat as well as protect the cable. The second type of the cable doesn't require fluids and it is the most current advancement in technology. The most common types of underground electric power transmission cable include the following, that is HPFF, high pressure fluid feed pipe, high pressure gas filled pipe, self contained fluid filled, and solid cable cross linked polyethylene. The high voltage underground cables used on national grid system, and it can be one of the three types, that is direct buried trough and tunnel. Undergrounding is the replacement of overhead cables providing electrical power or the telecommunication with underground cables. It demonstrates the higher technology in developed countries for fire prevention and to make the power lines less susceptible to outages during high wind, thunderstorms, or heavy snow or ice storms. An added benefit of undergrounding is aesthetic quality of the landscape without the power lines. Undergrounding can increase the initial cost of electric power transmission and distribution but may decrease operational cost over the lifetime for the cables. There are some advantages of undergrounding, that is it less subject to the damage from severe weather conditions. The second one is decreased the risk of fire, overheat. Overhead power lines can draw high fault current from vegetation to conductor, conductor to conductor, etc. Reduced range of electromagnetic field emission into the surrounding area. So that depending on the depth of the underground cable, greater EMF may be experienced on the surface. The underground cable need a narrower surrounding strip of about 1 to 10 meter to install. Underground cable pose no hazard to low flying aircraft or to wildlife. These cables have much reduced risk of damage caused by the human activities such as theft, illegal connections. The underground electric transmission, these cables have low visibility and not affected by bad weather, so but the cost of this cable is high. The finding of fault in underground transmission line takes much time for repairing as well as locating. This one is a disadvantage. So in urban areas, this type of transmission is enclosed with shielded with dielectric liquid and a metal pipe that is either fixed or sprayed through pumps. Disadvantages of this type is undergrounding is more expensive as the cost of burying cables at transmission voltage is several times greater than overhead power lines. Finding and repairing overhead wire breaks can be accomplished in hours, but the underground repair can take a days or the week. Underground cable locations are not always obvious, which can lead to unwary the diggers damaging cables or being electrocuted. Operations are more difficult since the high reactive power of underground cables produces large charging current and so make the voltage control more difficult. Underground cables are more subject to damage by a ground movement, and underground repair and checkup require a street digging and it creates a patches and the potholes. So these are the disadvantages. Thank you.